These two problems deal with aqueous reactions and net ionic equation. You're asked to classify the following as precipitation, acid-base, neutralization, or oxidation reduction or redox. Here you have mercury 2 nitrate reacting with sodium iodide to give you sodium nitrate plus mercury iodide. It's a solid, and it precipitated out when you put these two solutions together, so it is a precipitation reaction. The next one is a redox reaction, and you can tell that by looking at mercury, easily mercury and oxygen. Here, this is a mercury 2 ion, or +2. Here, mercury has an oxidation number of 0. So, just by that, you know there has been a transfer of electrons. And if you have oxidation, you clearly have reduction. You're not asked to find which one it is, but it is a redox, oxidation reduction reaction. Here you have phosphoric acid plus potassium hydroxide, which is a strong base, to give you a salt and water, which is the definition of neutralization. Your acid is phosphoric acid. The first hydrogen is a strong acid, but the other two are weak acids. It's a polyprotic acid. But to answer the question, it's a neutralization reaction between an acid and base. The next question is to look at the net ionic equation, and I will bring us down to that. What we do is you take your aqueous reactants, you break it up into ions because they are aqueous. Same thing with sodium iodide. You do get your precipitate. You have your two spectator ions, and they're specifically pointed out here. And here's your net ionic equation, which is the balanced equation without the spectator ions. And further down, you have your redox reaction. There is no solution. This is the equation, and it's not ionic, but that's your equation. For the neutralization, you have your acid, and your base is strong base, so it's broken up, and you have your products here. You have your spectator ions, which happens to be the potassium only, and finally your net ionic equation is given as phosphoric acid plus 3 hydroxides to give you 3 waters and the phosphate ion. And that's all there is to this.